Hello everyone, let's learn a new lesson, finding probabilities using counting techniques. In the case of the equality likely assumption, property of the event E, P of E equals N of E divided by N of S. What is the top? Top is numbers of outcomes for the event E. And N of S is numbers of possible outcomes in the sample space. Okay, the sample space has more numbers than the events. All right, let's see the first example. Alan, Bob, Carl, and David will be seated in the row for 4 chairs at random. So we have 4 chairs, and total we have 4 people. And we want to arrange 4 of them to sit in these 4 chairs. We can use the fundamental counting principles to solve this question. So for the first chair, I can select 1 person from 4. So I have 4 options. Alan, Bob, Carl, and David, I have 4 options. And after selecting one, for example, after I select 1 person, I have 3 left. So my second chair, I have 3 options. And then after selecting another person, I have 2 people left. So I have 2 options. The last position, I have only 1 person left. So I just say 1. So multiply them together. 4 times 3 times 2 times 1 equals 24. So 24 different ways they can be seated. If we are using permutations, the permutation says select. So the permutation we learned is NPR. NPR. So select R people or select R object from N, from the big pool. And then find the different orders of the R objects. That means we can select 4 of them. So 4P4. And then arrange the order of these 4 people. Find different ways they can be seated. We can use the formula, which is 4 factorial, all divided by 4 minus 4 factorial. The bottom is 0 factorial, which is 1. That is 4 factorial. We can simplify this, so we just put 24. You can also use a calculator. The calculator, it is here, clear. So we can click math, and then find the PRB, and then second one, NPR. So let's put 4P4, hit enter, that's 24. All right, let's see second question. How many different ways can Carl be seated in the first chair and Alan in the fourth chair? Okay, I have 4 chairs. First chair is Carl. And then in the middle, I have another 2 chairs. Last chair is Alan. So these 2 people, they are all settled down, or they are seated here. I can choose a person seated in the second chair from another 2 people. They are Bob and David. So my second chair has 2 options. Okay, so I can put 2. And the rest of the last chair, I have only 1 option. I can use a 2 times 1. Okay, 2 times 1 equals 2. All right, what is the probability that Carl will be seated in the first chair and Alan in the fourth chair? That is the probability of this event. So P of E equals N of E divided by N of S, the sample space. Sample space means 4 people, they are sitting randomly. And how many different orders do we have? So that is the the total outcomes we are going to have in the sample space, that is 24. And what is the top? So that is how many different ways Carl be seated in the first chair and Alan in the fourth chair. That is 2. Divided by 2, top and bottom, we are having 1/12. Okay, let's see. Second one, the previous one, we used the permutation, or we are using fundamental counting principles to get 24. All right, let's see. Second one, a group consists of 4 men and 5 women. 3 people will be selected at random to attend a conference. So we are selecting 3 from totally how many people? 4 plus 5. Totally we have 9 people. So let's put 9 people here. And the first question, how many different selections of people from the group are possible? We're selecting 3 out of 9. So we are using 9C3. We choose 3 people from 9, the big group or the big sample space. And we don't have to find the orders, different selections or different ways to be seated, or we just randomly grab 3 people from the big pool. So order doesn't matter. We're using combinations. What is the combination formula? We have 9 factorial over 3 factorial multiplied by 9 minus 3 factorial. Okay, the top is, the bottom is 3 factorial times 6 factorial. The top is 9 times 8 times 7 times 6 factorial. So do the cancellation. And then the 3 factorial is 3 times 2. 9 times 8 times 7. And then we can do the cancellation. It is 84. We can also use our calculator to put so select NCR. So put 9C3 84. Okay, number B. What is the probability that 3 people selected are all women? So we are looking for the probability. We're using the formula P of E equals N of E divided by N of S. So the sample space number of outcomes of in the sample space, that is how many different selection of 3 people from the group are possible. Randomly select 3 from 9 people. So the denominator is 9C3, or you just put 84 there. And on the top, what is the event? Number of the event. We are selecting 3 people. They are all coming from women. So totally we have 5 women. So we are going to choose 3 from 5. 5C3. Okay, on the top, I'm going to use my calculator to find 5C3. So 5C3, it is 10. So let's put 10 on the top and 84 at the bottom. They are all divisible by 2. So 5 divided by 42. And nothing can be simplified. That's the answer. And C, what's the probability that 3 people selected are all men? That means this time P of E equals N of E divided by N of S. And then denominator is 9C3 or 84. 9C3. On the top, selecting 3 people are from men. So totally we have 4 men. And then we are choosing 3 from them. Order doesn't matter. And then simplify the question. 4 divided by 84, and then divided by 4, top and bottom, we are having 1 over 21. All right, number D. What's the probability that 3 people selected with will consist of 2 women and 1 man? Why I highlight the and? And means multiply, or means add. So if I'm going to multiply 2 events numbers, so we're going to have P of E equals, the bottom is 9C3. So two women are coming from the 5 women group. So 5C2. And multiply by 1 man is coming from 4 men. 4 choose 1. And then simplify this. What are we going to have? We are going to have 10 out of 21. Okay, let's see number 3. 3 cards will be randomly selected from 52 card deck without replacement. What is the probability that will consist all hearts? So what does the 52 card deck look like? So 52 card doesn't have jokers. So we're going to have, for example, we're starting from ace. We're having ace. For the ace, we're having heart. We're having diamond. We're having spade. And we're going to have club. So, and then we're having king. King also have heart, diamond, and spade. For example, I don't write a lot. So for next row is queen and jack. What else? 10, etc. until 2. And totally, we're having 52 cards. So how many hearts do we have? 52 divided by 4, 13. So we are going to have 13 hearts. And how many diamonds do we have? We have also 13 diamonds. And how many kings do we have? We have 4 kings. King heart, king diamond, king spade, king club. All right, I talked about our cards. Let's see the question. What is the probability? Oh, talking about probability, we're always using the P of E equals N of E over N of S. Probability that it will consist of all hearts. So choosing 3 cards from 52 cards. I don't need to worry about the order. So that is 52. C3. That is the number of all possible outcomes in sample space. And the top, what is the event? It will consist all hearts. How many hearts do we have? Let's see. Oh, we already counted that we have 13 hearts. So we just say 13. And some of you say, I'm choosing 3 cards from 13. So we are having 13, C3. We need to randomly choose 3 cards from 13 hearts. All right, we can simplify this. We can use our calculator to help us. For example, you click 13C3, and then we're having 11 over 850. The second question, what is the probability that it will consist of exactly 2 aces? That means we have 2 aces and another card, because totally we have 3 cards. another card cannot be any of the ace. Okay, P of E equals N of E divided by N of S. The bottom is also 52C3 and the top. So 2 cards must be aces. So how many aces do we have? We're having 4 aces. We need to choose 2 from 4 aces. And what is the last card I'm going to have? I can choose any card from here. So I'm using 52 minus 4. That's 48. So I'm going to choose 1 card from 48. 48 C1. Okay, we're going to simplify our solution. It is 72 over 5525. Okay, let's see. Next example. What is the probability that will consist of 2 aces and a king? So 2 aces. 2 aces is coming from these 4. And a king. So maybe 1 king heart or heart king or diamond king or spade king or club king. Okay. What is that? And also we have an and. That means multiply. So N of E, P of E equals, what is the top? We're having 2 is coming from the ace. So totally we have 4 aces, 4 C2. And the last one is a king. So this card is coming from 4 kings, 4 C1. And denominator is 52 C3. Some of you say, it's too difficult for me to use calculator. I prefer to use my hand to do the computation. It's okay. So what is 4C2? We are having 4 factorial over 2 factorial. And then using 2 minus 2 factorial. Multiply by 4 factorial times 1 factorial times 4 minus 3. 4 minus 1 factorial divided by, most of you like calculator, right? So divided by 52 factorial divided by 3 factorial. And then multiply by 52 minus 3 factorial. And then on the top, let's simplify. We're having 4 factorial over 2 factorial times 2 factorial. And they expanded the 4 factorial to be 4 times 3 times 2 factorial. Do the cancellation. And 2 factorial means 2 times 1. And 2 and 4, we have 2 left. 2 times 3 is 6. So the first term is 6, first factor. And the second factor, so what is 4 factorial divided by 1 factorial is 1. 4 minus 1 is 3 factorial. 4 factorial means 4 times 3 factorial. Do the cancellation is 4. Okay, how about the bottom? So slow down the pace. We're having 3 factorial multiplied by 52 minus 3 is 49 factorial. The top is 52 times 51. 50 times 49 factorial. Do the cancellation. Top is 24. The denominator, the 3 factorial is 6, or 3 times 2 times 1. 6. And 52 times 51 times 50. Let's see. How about 52? How about 6 and 50 divisible by 2? 25. And then the top, then we have 3 left. So 52 divided by 3, what is that? 52 divided by 3, 1, 3, 22. No, it's not divisible. Let me use my calculator. My 52 divided by 3. It's not divisible. So how about 51 divided by 3? Yes, is 17. 17. So we are having 24 over 52 times 13 times 25. And then 24 and 52, they are all divisible by 4. Divide by 4, the top is 6. The bottom is 13. Wow, that's a big number. So we multiply the bottom together. We're going to have, so let's clear all of this part. So if I'm going to do the math, I'm going to have 6 divided by 5, 5, 2, 5. This is the probability. All right, let's make the screen clean. Next part, probability diagrams and probability formulas. So the previous example, you see this question has the and. And the previous question we have and. Previous question we have and. How about or? So later we are talking about or. But before that, let's see the diagram. A probability diagram is like a specialized Venn diagram in which probabilities of different events in the sample space are labeled. So in this diagram, we're not having sample space, the numbers. We're not having 3, 2, and 1. This is the probabilities. They are decimals. So event E, the probability of the event E, or we say P of E, is the blue shaded area. It is 0.3 plus 0.2 is 0.5. Okay, how about event F? Event F is a shaded area. Here, we're adding the decimals together. P of F equals 0.2 plus 0.1 is 0.3. And how about the overlapped area? So how about here? This is P of E and F. P of E and F. This is an intersection. And this section means the E and F happened at the same time. So the probability is 0.2. Okay. And how about the complement? For example, if I'm talking about P of E prime, what is the complement of E? We know that E is the area here. Complement means in the sample space, but not in E. So all of these, they are E prime, or we say the probability of a complement of E. Okay, this part we're using 1 minus P of E equals 0.5. Or you can add the probabilities together, because I see that here is 0.4 and here is 0.1. Totally, they are 0.5. Okay, let's fill out the blanks. What is P of E? That is the shaded area is 0.5. What is P of F? Is 0.3. And what is P of E and F? That is the intersection of E and F. Probability is 0.2. And what is P of E or F? So what is E or F? That is the section I highlighted. So we need to add them together. It is 0.3 plus 0.2 plus 0.1. it is 0.6. And what is P of E prime? We talked about this. It is 0.5. And next question, what is P of the complement of E or F? What is E or F? You say E or F is the area I highlighted. But we are looking for the prime or the complement. That is the outside area. That is blue area we're having. So they are not the red area. So we're having 0.4. So it is 0.4. Okay, let's see next question, next part. A formula of P of E or F. Oh, E or F. That is a section here. What's the meaning of that? If I'm looking for, this is a probability diagram. I'm going to add X, Y, and Z together. That represent P of E or F. So X plus Y plus Z. But I have learned that P of E is a section here. And then P of F is a section here. So between the E and F, we have overlapped section. We call the Y part. So in the Y part, if I'm adding the P of E and P of F together, so I have added the overlapped area twice. So I need to take away one time of the P of E and F. So the overlapped or the intersection area. Okay, that means P of E or F equals P of E plus P of F, then minus P of E and F. And if E and F, the overlapped area, the intersection is empty set, is phi, then it's impossible for both events to occur, and they are called mutually exclusive event or independent. So two events, they are independent. And some book will say disjointed. Disjointed. For example, if I have two events, event F and event E, the intersection is empty set, so no intersection. F and E, they are mutually exclusive events or independent or disjointed two events. That means E or F. E or F, or means add. E or F, we add two probabilities together because there is no intersection. I know that previous example we learned a formula. If I'm adding P of E and F, so this part is 0 because there is no probability happened that these two events overlapped to each other or intercept each other. Okay, this part is 0, so I'm going to erase it. And also the intersection is empty set. Okay, let's see next example. Formula involving P of E prime or the complement of E. So we are having a E here. What is the complement of E? Okay, that is still in the sample space, but is not E. So it is the shaded area here. Okay, so 1 equals P of S, that's the probability of sample space, equals the X part plus Y part. And the X represent P of E, and P of E prime, it is the shaded area. The sum of these two will make a 1. So if I'm isolating P of E, it is 1 minus P of E prime. if I'm isolating P of E prime is 1 minus P of E. Okay, let's see. Out of context example. So P of A is 0.7 and P of B is 0.4 and P and B equals 0.3. Where I'm going to start? I'm going to start from the intersection. Here, the A and B, or P of A and B is 0.3. And A is 0.7. That means the only A part is 0.7 minus 0.3. It is 0.4. So I'm going to only put 0.4 here. Let's put 0.4 here. And P of B is 0.4. So this section is 0.4. I'm going to use 0.4 minus 0.3. It is 0.1. So let's only put 0.1 here. And I'm curious about the complement. How about this section? How about this section? I'm going to use 1 minus 0.4 minus 0.3 minus 0.1. Okay, so messy. So let's use 1 minus 0.4 minus 0.3 minus 0.1. It is 0.2. Okay, let's see. What is the probability of A or B? So A or B is a section here. So add them together, 0.4 times plus 0.3 plus 0.1 is 0.8. What is the P of A prime? Where is A prime? Is using 1 minus 0.4. Is a section, 1 minus P of A minus 0.7. So I'm using 1 minus 0.7. It is 0.3. And how about P of A or B prime? What is A or B? Let's highlight A or B. So A or B is here. The prime means 1 minus the section. So I'm using 1 minus the section. 0.4 plus 0.3 plus 0.1. If I'm saving some space, we're having 0.2. Okay, what is the probability of A and B prime? So what is the B prime? Let me ask you. B prime is the area here, but not B. So is a section here. So I'm using this area to intersect A because it is A or B, A and B prime. What is the intersection? The intersection of this with A. So let's highlight the A. Which area I graphed twice, or we have an overlapped intersect area. Everybody can see it clearly. Okay, I'm going to highlight that area only. So it is 0.4. So I'm going to put 0.4 here. Next question, P of B and A prime is the same thing like the previous example. It is the section here. B and A prime is 0.1. Okay, how about next example? The probability of the prime of A and B. So A and B is 0.3. And 1 minus 0.3 is 0.7. Last one. P of A or A prime. What is the A or A prime? That means P of A plus P of A prime, and then minus P of A and A prime. I know that A and A prime must be phi. And it must be empty set because A and is complement, no overlap. So P of this is 0. This probability is 0. So this part is 0. I just cross it out. What is the probability of A plus probability of A prime? Is 1. We have learned that because probability of an event plus probability of its complement of this event must be 1. Okay. All right, let's see the example. In context example, a card is randomly selected from a standard 52 card deck. Oh, this question. What is the P? What is the P? Oh, sorry. N of E over N of the sample space. Sample space is we randomly select one card from 52. That means 52. 52. C1. And then this card is ace or heart. I really want to move the notes down here because we are having ace, the heart, the diamond. First two, they are red. And we have spade, and we are having the club. All right, and we are having king, queen, jack, 10. We have 2. Okay, so the event is the card is an ace. So is an ace or is a heart. Is a heart here. Okay, so we are having or event. That means we're going to have P of ace plus P of heart. And then minus P of A and heart. Ace or heart. Okay, really wish I have enough space on the top. What is P of A? The probability of getting an ace is 4. So 4 is a 4. Oh, I got a problem. I shouldn't put a P. I'm having N because right now on the top is N. You see here is N, but the same thing. So let's put N here, N here, N here. Okay, we're going to have 4. And then what is N of heart? So how many hearts do we have? We have 13 hearts. And then minus the overlapped. So this card is both ace and heart. That is the card here. We have only 1 divided by 52 because 52 C1 is 52. And then we can simplify this solution. We are having 16 divided by 52, which is which is 14 over 13. Okay, and how about the next example? So some of you say, can I break this one down? And then I'm not using the N of E divided by N of S. Of course, you can also use this formula. We have learned the P of A or K, ace or king, equals P of A plus P of K, then minus P of A and K, ace or king. Okay, what is P of A? So the previous example, we are using N over N. So on the top is N, At the bottom is also n. And now we are only using p. So you see p equals p. Okay, p of a. The probability of finding an ace is 4 over 52. Totally, we have 4 aces. And the p of king, how many kings do we have? We have 4 kings. 4 over 52. And how many cards? They are both ace and king. We don't have any card that both ace or king. They must be ace only or king only. So I select a card cannot be ace and king at the same time. So they are independent two events. So the P of A and K is 0. I just erase this. All right, we can simplify this question is 8 over 52. And then simplify this is 2 over 13. How about the next example? Face card or a club. So probability of selecting a card, it is a face card or club card. So if I'm using the formula here, I feel this one is easier. But this one is also a very good one. Okay, so what is the formula? P of F plus P of club minus P of F and club, face or and club. So P of F, the card is a face. So how many face do we have? So king, queen, and jack, they are all face card. So we are going to have 12 face card divided by 52. And then plus probability of a club. So how many clubs do we have? We have 13 clubs. So we put 13 over 52. And how many card we are having face and club? So we are going to have club here. And the 3 of the face cards, they are having king club, queen club, jack club. We are having 3 of them. So 3 of them, that means 3 out of 52. Okay, combine the tops, 12 plus 13 minus 3 over 52. It is 25 minus 3 is 22 over 52. It is 11 over 26. All right, let's see next example. A survey of North Harris student. We had this table before, but you see these are all the numbers, sample numbers. They are event numbers. They are not the probabilities. Probability must be 0 point something. Okay, let's see. A student from the survey is selected at random. Wow, what's the meaning of a student is selected from this big survey? Totally, we are having 100 students. And then we are selecting one from 100. That means if I'm using this, if I'm using the finding the n of S, sample space is 100. I'm going to select one student out of 100. Okay, let's see the first question. Probability of a sausage or mushroom. What's the meaning of probability of sausage or mushroom? So this formula is P of S, sausage only, plus P of mushroom only, minus P of sausage and mushroom. So what is P of sausage? I'm going to see. Probability of student who's selecting sausage, but this is 35. The P equals N of E, or N of sausage divided by n of sample space 100. So we're going to have 35 over 100. What is probability of mushroom? Mushroom is 100. So 10 over 100. And minus P of sausage and mushroom. No student can select two different pizza toppings. So they can only select sausage or mushroom. So mushroom and sausage, there's no overlap. That means probability is 0. So we can just stop here. Add the tops together. We'll have 45 over over 100 is 0.45. You can simplify this. You can have 9 over 20. Or you can give me 0.45. Okay, next example, freshman or pepperoni. So P of F plus P of pepperoni minus P of F and pepperoni. And P of F, probability of selecting, they are freshmen. Totally, we're having 45 freshmen. So we are using 45 over the sample space numbers. So 45 over 100 plus probability of pepperoni. Pepperoni, totally we have 55. It is 55 over 100 minus the overlap. Do we have overlap between the freshman and pepperoni? Yes, we're having the cross section. The pepperoni and the freshman. The freshman who's selecting the pepperoni, we are having 25. So that is the intersection between the pepperoni and the freshman. So 25. Let's put 20. We're having a minus. Minus 25 over 100. And then we can add them together. We're having 75 over 100 equals. You can simplify the top and bottom by dividing by 25. 3 over 4. You can also say it is 0.75. Okay, that's the last question of this lesson.